Hi, it's John von der Heijden here. I'm just putting together a little video to show you why I think VLOOKUPs suck. To be clear, I don't actually think that VLOOKUPs suck, but I do think that there are ways in which we use VLOOKUP that suck, and I also think that many of us tend to be a little bit over-dependent, a bit over-reliant on VLOOKUP, and really I want to show some alternatives. I want to show you why they suck, and then I want to show you what the alternatives are. So I have set up a bit of a demonstration. I have a whole bunch of records. That's 100,000 records of social security numbers, first name, last name, date of birth, gender, and telephone number. And it might seem like a very large table, and you might be thinking, well, I don't deal with record volumes of such as this. But I suppose the reality is that you probably are dealing with models where you've got various different tables or sheets of information, and you're doing VLOOKUP sort of all over the place. And this is perhaps just a more succinct example of that. So bear with me. I still think this is going to be relevant, even if you're not dealing with record sets of 100,000 or more. Okay, so note that this table is in no particular order, and particularly social security number. It's not in ascending or descending order of social security number. This is completely random. And speaking of random, I should also illustrate that this is random data. It's not real data. These are fake social security numbers and names and dates of birth, etc. Okay, so I have another sheet in here. I've called it my results sheet, and you will see that I have got, how many have I got? 1,500 social security numbers, and I have these empty fields for first name, last name, date of birth, gender, and telephone number. And my objective is to retrieve these fields for these social security numbers from our data table. It's not an unlikely scenario. You probably do the same. You receive some information back that has a whole bunch of keys, and you need to index those individual keys against a lookup table of some description and return field values for that. So that's exactly what we're doing. Just notice in row 1, I've got a whole bunch of index numbers here, so 2, 3, 4, 5, and 6. Those indicate the columns of this table that I want to return information from. So our key is going to be in column A. And therefore the first table field to index to return information from is our first name, so that'll be our number 2 over there is the second column of our lookup table. Okay, so to write the VLOOKUP, something that hopefully you are somewhat familiar with. So I've got VLOOKUP, what am I looking for? Social security number in A3 against my data table, columns A through to F, and I want to return information from the index number that we're housing in row 1, and I'm going to type comma false at the end. So the false argument value at the end indicates that I want to perform an exact match VLOOKUP. So there are 2 variants of VLOOKUP, exact match and approximate match, and we'll discuss how they work in a minute. What I do want you to pay particular attention to now is the amount of time it takes to calculate the results. So as soon as I paste this, it is going to attempt to return the first name, last name, date of birth, gender, and telephone number for each one of these records, of which there are 1,500. So ready, steady, go. And if you look to the bottom right, you will see the calculation spin up. And let's just get some idea, some feel for how long this method takes. You can see already that it's far from efficient. It's certainly not the fastest formula. And this is why I actually believe that when I appraise other people's models, for certain clients, this is one of the first things I look for, are these exact match VLOOKUPs, and I see if I can improve on them and sort of implement something a bit different. So I'll just keep babbling on until it's finished calculating. I don't exactly know what to say, but around the 80%, say 85%. Oh, come on. Awfully slow. Hooray, we're there. Okay, so we've got our results at last. That was far from quick. Okay, so you can see the results are there. Just pay particular attention to row 6. You can see that we have hash NA, which indicates that social security number 264416642 is not found within our data table. So I'm sure you're quite familiar with these NA errors. So I'm going to explain to you how it works and a couple of other sort of observations. So firstly, VLOOKUP exact match uses what's called a linear search. It's a sequential search. It will take the social security number, for instance this one in A2, 820818858. It'll go to the lookup table, the index, and it will start from the top and sequentially search through each social security number one at a time from top to bottom until it finds the social security number. When it finds the social security number, it will return the value that is adjacent to the social security number based on the column index. So 2 for the first name, 3 last name, etc. That means if it does not find it, for instance with 264416642, that's social security number kept in A6, it will have scanned 100,000 social security numbers in order to be able to determine, hey, the social security number is not in this table. So that's the first observation. That's a linear search. The second observation is that we have a VLOOKUP in column B, C, D, E, and F. That means it has to perform a VLOOKUP to return the first name, and then essentially it has to repeat that entire scanning process again to find it for the last name, and then the date of birth, and the gender, and the telephone number. So quite obviously, it would be far more efficient if you could sort of say, hey, okay, I found it, my social security number is there, and now from that position return first name and last name, date of birth, gender, and telephone number without having to do all the scanning again. So that's sort of the desired output, or desired way that we would have it work. Okay, so let's start to talk about an alternative. So if you were to index a telephone directory, so forget Excel, and you're doing this, physical book, and you're looking for, I don't know, Microsoft in this telephone directory, you're going to take a much more smart approach. I mean, you can imagine opening up on the first page, looking at the first item, saying, okay, this isn't Microsoft, and then sequentially seeking each item and turning each page until you find Microsoft is going to take you a very, very long time, and you're going to grow very old doing that. So the intelligent approach that you apply is you'll sort of take the telephone book and you'll open around about the halfway mark, and you will look at the name that appears on the top of the second page, the page on the right hand side after you've opened the book. And if you have landed on a letter that is less than M, then you know that Microsoft will be found in the rightmost part of that telephone directory, and otherwise it will be in the leftmost. If you landed on Microsoft, well, woohoo, good job, you got lucky. But what will happen is you'll repeat this process. So you'll discard one half, and then you'll split that remaining half in half again, and on and on and on until you find the item that you're looking for. And that's what we refer to as a binary search. And in Excel, we can use binary search with VLOOKUP, HLOOKUP, match, and normal lookup. So with normal lookup, HLOOKUP, and VLOOKUP, like a telephone directory, the information has to be in order, and in particular for these functions, that has to be in ascending order. Match can handle the information held in ascending order or descending order. So obviously that's a crucial element. Your information must be ordered, and that might not be possible if you've got more than one lookup to perform on the table with more than one key. In other words, you're not just doing a search by social security number, but potentially also by, say, telephone number. You can't have your information sorted both by social security number and telephone number. Not simultaneously. You can have primary and secondary sort fields, but this has to be the primary. Okay, so that's a genuine constraint. The other thing that you need to be aware of is that with binary search in Excel will return a result from the item that is larger, the largest item rather, that is less than the lookup value, if the lookup value could not be found in that table. So in the case of 264416642 in A6, the social security number that could not be found, if we did a binary search on that, it would match, for instance, social security number 264416641. That would have been, if that item is in there, the largest item that is less than the social security number. That means you're getting an approximate match result, and that's why we call this variant of function the approximate match method. Okay, so the short story is it doesn't give you the answer that you want, but we can deal with that, and I'll illustrate that in a moment. The first thing I want to demonstrate is the speed, the efficiency of the binary search over the linear search. So although I'm going to get incorrect results in row 6, which we will deal with shortly, the key message here is to identify the performance improvement. Okay, so I have literally only changed the argument in the VLOOKUP, the very last argument, from false to true, which passes the instruction to perform this linear search as if you were searching a telephone directory. And I'm going to paste this down, and as soon as I hit OK, I want you to observe the calculation time. Ready, steady, go. Okay, that was instant. I didn't even see anything in the status bar on the bottom right. You can see that row 6 is now saying it's found something, and we've got NAs in some sort of other odd spots. And the reason for that is, well, firstly, our information in our data sheet is not in ascending order. That's a constraint that we have to manage. And secondly, we would certainly expect row 6 to have NAs because it was not there. Okay, so I'm going to show you how I deal with this. So I'm going to take all of this gump out. I don't want this VLOOKUP in here at all. I'm going to go across to my data table, and I'm going to determine, can I sort this information? So quite clearly, with a table like this, we should be able to maintain a sort order. So if you're wondering, how do I maintain a sort order? Well, if you're using a query, for instance, to import your data, you will have your sort order embedded within the query definition. So that's another lesson for another time. I'm going to put this in ascending order by social security number. Boom, that's there. Awesome. Okay. Now what I'm going to do is I'm going to use helper columns. So you might think, okay, I'm making the file bigger using helper columns. Well, rather a little bit bigger, and it's negligible, the amount of increase. Rather a little bit bigger and have huge performance benefits. Okay, so in here, I want to know, where does it find my social security number as an index? It's a row index, so perhaps I should be calling this row index. So that's my helper column. So quite simply, just a match. Match A3 in this case. Okay, I don't actually need my little dollar symbols in there. I'm not going to be dragging it across anywhere. In column A and comma 1. Comma 1 means I am looking for this in a table that is ordered ascending. So match supports ascending, descending, and exact match method, and so this is ascending. All right, so I get my results, and I am just going to paste that formula all the way down to the bottom. So just bear with me, this is going to click pretty soon. So we know that row 6 should not be found. So it says it is making a match in row 18,165. So that indicates to me that it is probably matching social security number 264416641, not 6642, the largest item that is less than the social security number. So obviously that's the wrong answer. So the next step is to work out, did it find it? So in H2 I'm using this field now called found. So what I'm going to say is, if I index my data sheet, my social security number, using my row index, is it the same as my lookup value, which is in my A3 over there? And this will say true if it is, otherwise false. So I can copy and paste this down, and the first thing to observe, row 6 says no, that was not a match. And that's great, because at this point I have used a single column to identify the location of the matching item that I want. I can use my column H to determine, well, should I be returning NA or instead because it wasn't found? And on that basis, I can revert to the index worksheet function. So I can say index from my data table, my first name column. What do I want to return? I use my row index number to return the results. And I can nest that within an if statement. If my found result, then do that. Otherwise, in other words, if it's found, index my column of interest and return the item corresponding to my index number, my row index number. Otherwise, return NA as we would have had displayed had we used an exact match VLOOKUP. Copy and paste that down. Boom, you can see that the results are absolutely instant. So if you want to know the sort of performance improvement here, yes, I've got a few more bits of logic going on. I'm occupying a few more columns, but basically you're looking at sort of 300-400 times, if not more, speed improvement. And if you implement this sort of a method within your models, and you really try and make the binary search methods your default. So that obviously means you've got to put consideration to how you structure your data or how you order your data, and use of helper cells. If you do that, it is honestly what makes the difference between some models that I've observed that take sort of 20 minutes to calculate to something that takes seconds. An example of that was not too long ago. I dealt with a model that took 25 minutes to calculate. 15 minutes after playing around with it for about 15 minutes, I I swapped the VLOOKUPs around for binary search methods. So yes, I had to put in a couple of helper columns. I had to put some order to the information, and I brought that down to 6 seconds. So top tip, I hope you enjoyed it, and good luck.